What is going on, everybody? It is your boy P, and today we're going to be looking at an introduction to uniform circular motion. And so we're talking about uniform circular motion. We have to have a circle of radius r and an object that moves along the circle at a constant speed. Again, an object that moves along the circle at a constant speed. Now, although it has a constant speed, that is not to say it has a constant velocity. Velocity is a vector quantity and has both magnitude and direction. While the magnitude remains the same, the direction constantly changes. The direction of velocity is tangential to the circle. At any point along the circle, the velocity is moving, the direction of the velocity vector is the direction of the object's motion, tangent to the circle. So with the velocity, we understand that at any point the velocity is changing. And so if the velocity is changing, there must be some acceleration. And acceleration is directed, the direction of the acceleration vector is at the center of the circle. And knowing that it's at the center of the circle, we can say that the acceleration vector and the velocity vector are perpendicular at any instance around the circle. And the magnitude of our acceleration can be related as the velocity squared over the radius r. And now, if we think about this, the direction of our velocity vector increases more rapidly as our speed goes up. And if we have a longer radius, it takes longer for the direction to change. Thus, we have the equation, the magnitude of the acceleration equals the velocity squared over r. Now, if we have an acceleration, we also have a force, okay? And our force is in the same direction as our acceleration, directed toward the center of the circle. Now, we call this force centripetal force. And the same with acceleration, we call it centripetal acceleration. So, using Newton's second law, force equals mass times acceleration, we can say that the force equals mv squared over r, just substituting a equals v squared over r. So we have an equation for the magnitude of our acceleration and an equation for the magnitude of our force. So to summarize, an object that moves at a constant speed along a circular path has a velocity vector that has a direction tangent to the circle and a acceleration vector that is perpendicular to that velocity vector, and its direction is towards the center or the axis of the circle. Now with that acceleration, we also have a force, and that force is also directed toward the center of the circle, and we can relate acceleration as v squared over r, and then force as mv squared over r. I hope you guys enjoyed this video, and as always, the more you know, the better you are.
We've gotten strange, we've gotten older. It'll be alright. I miss the days when we were sober, but it'll